Hi everyone, Mrs. V here, and today we are looking at the second part of our series on double replacement reaction. We are going to look at the reaction between acids and metal oxides and acids and metal hydroxides. So let's get that whiteboard on and get started. Now we have already looked at one acid reaction when we were studying our single replacement reactions. That was the reaction between acids and metals, which gave metal salt and hydrogen gas. And we need to remember that acids all react the same way, but they make different reaction products. So hydrochloric acid always makes chloride salts, and your sulfuric acid always makes sulfate salts. Nitric acid makes nitrates, acetic acid makes acetates, citric acid makes citrates, etc., etc. So this is because all acids contain hydrogen and they all release their hydrogen as H+ when you dissolve them in water. And it's actually the H+ that's responsible for the acid reaction. The other part of the acid just becomes part of the metal salt. So let's have a look at hydrochloric acid here. So if you can think of hydrochloric acid as being made of H+ and Cl-. So in the diagram here, we've got the green ones representing the chloride ion and the white ones representing the hydrogen ions. So when you dissolve it in water, then you end up with these hydrogen ions being surrounded by water molecules. Notice that because the hydrogen ion is positive, the negative ends of the water molecules are pointing in toward that positive. And then we have the chloride ion being negative, also surrounded by water molecules, but notice that the positive end of the water is pointing into the chloride this time. So hydrogen chloride, when you put it in water, actually becomes hydrogen ions and chloride ions. And this is where we get our chloride salt from the Cl-. So that combines with the metal to make the metal salt. If we were looking at sulfuric acid, H2SO4, that's made of 2 hydrogen ions and a sulfate ion. And that is why you get a sulfate salt with sulfuric acid. Then if you looked at nitric acid, that's made of an H+ and a nitrate ion. And that is why you get nitrate salts. Now, that was a single replacement reaction, but many acid reactions are actually double replacement reactions. In particular, we're going to look at acid plus metal hydroxide and acid plus metal oxide. These are neutralisation reactions. They make a metal salt and water. And what you actually find is that those hydrogen ions from the acid combine with the hydroxide ion or the oxide ion, and that's where the water comes from. And then you get your negative ion from the acid combining with the metal ion, and that makes the metal salt. So that's why it's a double replacement. So if you think of your acid as being sort of HCl, and your metal hydroxide is maybe sodium hydroxide, then it's a swapping partners, a double replacement. The hydrogen is going to get with the hydroxide, and that's going to make your water. And the chloride from the acid is going to get with the sodium, and that's going to be your metal salt. So that's how these reactions work. All right, let's have a look at a couple of examples, and we're going to write some equations. So we saw in the video the reaction between sulfuric acid and copper oxide, and you'll remember that that made copper sulfate, copper 2 sulfate, and water. Copper 2 sulfate was the blue solution. Now, if we write the formula for sulfuric acid, H2SO4, and the formula for copper 2 oxide, which is CuO, then what's going to happen is that we are going to have the hydrogens and the oxygen getting together, and that's going to make our water. And we're also going to get then the copper ions and the sulfate ions combining, and that's going to be our copper sulfate. So this is how the reaction is working. And we saw in the video that that equation is already balanced, and we just put in the states, aqueous for acids, our copper oxide that we used was a solid, the copper sulfate was in solution, and the water is a liquid. All right, let's try one more here. Then I'm going to get you to have a go. So hydrochloric acid is HCl, and sodium hydroxide is NaOH. So what are we going to produce from this? According to the general equation, we're going to get a metal, salt, and water. Now, our metal is sodium in this example. And our salt from hydrochloric acid is chloride. And you can see how this occurs because the double replacement is going to have the sodium going with the chloride, and it's going to have the hydrogen going with the hydroxide. So this is where we're going to get our water from, and we're going to get sodium chloride. And this is another equation. If we check our elements inventory, we'll find that's already balanced. So we have hydrogen, chlorine, sodium, and oxygen. So we have 2 hydrogens, 1 chlorine, 1 sodium, and 1 oxygen on the left-hand side. And if we do the inventory over here, hydrogen, chlorine, sodium, and oxygen, you'll see that we have 2 hydrogens in the water. We have 1 chlorine in the sodium chloride, 1 sodium in the sodium chloride, and 1 oxygen. So that equation is already balanced. Now, I would like you to have a go at the next one, nitric acid and calcium hydroxide. So the first thing I want you to do is pause the video and predict the products. Okay, how did you go? Acid plus metal hydroxide gives metal, salt, and water. The metal we're looking at this time is calcium. And nitric acid produces nitrate salts. So we're going to get calcium nitrate and water. Now we need to write the correct chemical formula for everything in this equation. So nitric acid is HNO3. It's going to take you a little bit of time to get used to the acid formulae, but it would be good if you knew hydrochloric acid, sulfuric acid, and nitric acid, as they're the common ones. Now we're going to do calcium hydroxide. So calcium hydroxide is an ionic compound made of calcium ions and hydroxide ions. Calcium is in group 2 of the periodic table, so that is going to form a 2+ ion. So with our Lego brick method, we're going to draw that as a 2 block. The hydroxide ion is a polyatomic ion, it's OH-. So because that has a charge of -1, it has a valence of 1, and therefore we draw that as a 1 block. Then we can see we're going to need 2 of those. And so when we write the chemical formula for calcium hydroxide, it will be CaOH twice. Remember to put the OH in brackets. Polyatomic ions, if you need more than 1, you've got to put them in brackets. Okay, on to calcium nitrate. Again, we see the calcium ion. And this time we're combining it with the nitrate ion, which is NO3-. So this is again has a charge of -1, and therefore it has a valence of 1. So we can see then that the formula of calcium nitrate is CaNO3 twice. Remember, polyatomic ion goes in brackets, and plus water. All right, now we can do our elements inventory and see if this equation is balanced. So we have hydrogen, nitrogen, oxygen, and calcium. And we'll do that on the other side as well. Hydrogen, nitrogen, oxygen, and calcium. So let's count them up. On the left-hand side, we have 1 hydrogen in the nitric acid and 2 in the calcium hydroxide, so that's 3 altogether. We have 1 nitrogen in the nitric acid, that's the only one. The oxygens, we have 3 in the nitric acid, plus another 2 in the calcium hydroxide, so that's 5 altogether. And calcium, we just have 1 in the calcium hydroxide. Moving over to the right-hand side, we have hydrogens, 2 in the water. Nitrogens, we've got 2 because the nitrate ion has been taken twice. When it comes to oxygens, we've got 6 in the nitrate ion, 2 3s, plus another 1 in the water, so that makes 7, and 1 calcium. Now, looking at that elements inventory, things look out of balance, and they look out of balance in a pretty ugly way. But if we just follow our standard procedure for sorting out our equation balancing, that is leaving oxygen until last and leaving hydrogen until second last, we should be able to work through this. So the calciums are balanced, the nitrogens are not. We can see that on the left-hand side of the equation, we have 1 nitrogen, on the right we have 2, which means we're going to have to double up our nitrogen-containing compound on the left. So we're going to need 2 nitric acids. That's going to give us our 2 nitrogens, but now that's also changed the number of hydrogens. So now we've got 2 hydrogens in the 2 nitric acids plus the 2 that are in the calcium hydroxide. So now our hydrogens are at 4. Our oxygens have changed as well. Now we have 6 oxygens in the 2 nitric acids, plus another 2 in the calcium hydroxide. So altogether now we have 8 oxygens, and we still have just the 1 calcium. Now we sit back and take another look, and we can see what's out of balance now is oxygen and hydrogen. We always leave oxygen till last, so let's do hydrogen. So hydrogen, I have 4 hydrogens on the left-hand side, but I only have 2 on the right-hand side, which means on the right-hand side, I'm going to need to multiply the hydrogen compound by 2, and that will bring that up to 4. But having multiplied water by 2 also has multiplied that oxygen by 2, which means now for oxygen, we have 2 oxygens in the water plus 6 in the calcium nitrate. So altogether we have 8. Sit back, have a look, and fantastic, our equation is now balanced. If you found this video useful, if the explanation has really helped you with your chemistry, then please consider giving the video a like, and also subscribe to my channel for more explanations of balancing equations and all things chemistry. I'm going to see you guys in the next video.